Welcome to the lecture, my dear students. Today I'm going to do the application of integration, where how to find out the area between a given curve and the y-axis and the abscissa. So what do you mean by this? What is the area which has been measured, which has been of the area of a particular region which is bounded about this axis? Let us say now, for example, I have y-axis and the x-axis. I wanted to find out some curve, and now let us say that let us have this curve like this, suppose. Now I wanted to find out the area which is being bounded by a particular region in between y-axis and the curve. It is like this, suppose. Okay. Now I wanted to find out this region, and also if I just say this between y-axis and the curve means this is the whole region. So I have to give a boundary for that around the y-axis also. So and the and the abscissa. Abscissa means what? The points here, let us say y is equal to a, and this is y-axis, this is the x-axis, and in between x is equal to a to b. So the straight line between y is equal to b is this line, y is equal to a is this line. Now I wanted the region which is bounded by this particular area. Clear? So now to find out the area of this particular region, the formula for this is now integral of a to b. Now the function is defined as in terms of y, because the function has been f of y dy modular. So this is what the area of the region bounded in between the y-axis and the curve. Let us now solve a problem. So find the area bounded by the curve x is equal to 3y square minus 2y, the y-axis and the abscissa y is equal to 1 to y is equal to 4, let us say. Now how to find out the area generated by this particular region? So what is the formula for this? A is given by integral of a to b f of y dy. What is f of y here given, and the limits are from 1 to 4. So just do 3y square minus 2y dy. The given function is this, right? So 3y square minus 2y dy. So what it gives us? It is 3 times of y cube by 3 minus 2 times of y square by 2. Now that gives you y cube minus y square within the limits 1 to 4. So apply the upper limit minus the lower limit. 4 cube minus 1 cube minus 4 square minus 1 square. So what is this? It is 64 minus 1, that is 4 minus 1, and this is 16 minus 1, that is 48. Now since it is the area, it is 48 square units. I hope you could understand how to find out the area between the curve and the y-axis. Okay. Let us now do one more problem as like this. Let us say, let us take one more problem. Find the area between the curve x is equal to, let us say, y square minus 4y and y-axis between the abscissa y is equal to, let us say, 0 to 3. Okay. So now the formula is what? To find out the area, it is the modular value integral a to b f of y dy. So that is modulus of integral 0 to 3 y square minus 4y dy. Let us solve the integral. Y cube by 3 minus 4y square by 2 within the limits 0 to 3. So it gets cancelled. So it is 3 cube over 3 minus 2 times of 3 square. Anyhow, the lower limit is 0. Okay. So that is 9 minus 18. We want the modular values, of course. So it is 9. It is equal to 9 square units. So this is what the way to solve the problem, to find out the area between the curve and the y-axis. So with this we have completed area between the x-axis in the previous lecture, area between the curve and the y-axis in this lecture.